Hello and welcome to the second part of the lenses miniseries. Here I will show you a simulation on the lenses with an in-depth. First, you see that we're using our two lenses, the convex or the converging lens and the concave or the diverging lens. There are three ray lines that we use with these lenses. One is the parallel line, that is this line right here, and that bends towards the focal point on the right hand side, as you see as it reflects inside the lens. Second is the center line, which passes through the center of the lens. That will always pass through the center of the lens, no matter which lens you are using, be it convex or concave. It always passes straight through. And when I say convex and concave, convex means converging and concave means diverging. Not want anyone to be confused. The third line is the line that passes through the left focal point. That passes through this left focal point and goes parallel on the right hand side. So it is a complete mirror of our first parallel line. Now, in case of a concave or diverging lens, you see that the parallel line bends away from the focal point. As I told you in the first video, that is the definition of a diverging lens. So, remember, we trace back the refracted light and it comes through this focal point. The center line, which I already showed you, goes through straight. And the line to the focal point, instead of going through the left focal point, tries to go through the right focal point in a diverging lens, and it still goes parallel. But as you can see with this, we trace it back here when we want our refracted line. And as you see, the trace back lines all converge here, so our virtual image is created here. Now, I will show you what happens when you move the object, first in a converging lens, closer to the focal point. As I move it closer to the focal point, you see the image on the right hand side gets bigger. And as I move further away, it gets smaller. But once I come inside the focal point, however, in a converging lens, the image goes behind and becomes virtual. As you can see right here, this is the base of a very large candle. Now, with a diverging lens, I apologize for the outside noises. Now, in a diverging lens's case, as I move further away, we still see the same thing happening. The image gets smaller, and as I move closer, the image gets bigger. But once I get inside the focal point, you see that the image does not go on the opposite side of the lens, as in a converging lens's case. It instead stays a virtual image right there. Now, that is all I will show you in the second part series, and I hope you will tune in for a third part series where we will solve an equation about lenses. Thank you.